Okay, let's try this again. Fun fact, I already did this once, and my headset, or my microphone, excuse me, that I was using, apparently decided to stop working halfway through. So, round 2. We're going to go ahead and look at an exponential function. An exponential function looks like the following. Some base number, b, to the x value. I'm sorry, to the x value. Meaning that x is the exponent. So, for example, 2 to the 4th or 3 squared. Instead of an actual 2 to the 4th, it's going to be 2 to the x, 3 to the x, 5 to the x. It could be a half to the x. It could be 2/3. It could be 5 halves. It could be 2/7. Some value to the exponent, to an exponent. This is what's called the parent function, so everyone will have the same kind of shape. So he won't be moved up or down or left or right or reflected or anything today. Just general graph. So if the b above is greater than 1, it's considered to be an exponential growth. And it is considered to be increasing. So from left to right, we're going in a positive manner. It won't be a straight line, but it'll still be going in a positive fashion. Oppositely, if it is less than 1, it's considered to be an exponential decay. And is considered to be decreasing, which would look in a negative fashion. Next, we have an asymptote. An asymptote is a specific thing. It's a line in which the graph gets really, 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 really close to but never, I'm running into my face, crosses. So we'll get really close to a line, but we won't actually cross that line. So it's kind of like getting in trouble. You know where to like put your line on the toe. You know where to put your toes on the line, but you don't actually go across it. Well, some of you would. Anyways, think of that. All right, here's my first example, 2 to the x. So since I have the b value 2, he's going to be an exponential growth, and he's going to be increasing. So from left to right, I should be going up. That was really hard to do because I'm going backwards. What we're going to start off doing is creating an xy table, and we're going to use the values -2, -1, 0, 1, and 2. We're going to see if I can use any negative values. Sometimes we can use negative numbers, sometimes we can't. So we're going to get our handy dandy calculators. And if you don't have yours or have one on with you right now, please go pause the video so that everyone can get one. So in our calculator, we're going to want to make it look like this. That's a lot more difficult than you think it would be. So 2 to the -2nd. If you have one of the newer calculators, it'll put that -2 up in the exponent for you. If you have just one of my basic blue ones, you still will have that button. It's the caret E. It looks like this. And we should come up with 0.25. When we do to the -1st, I should get 0.5. We know anything to the 0 is 1, 2 to the 1st is 2, and 2 squared is 4. Now we talked about this asymptote line. An asymptote line is a line that can't cross. So the line we are not going to cross today is going to be the x-axis. Because with an exponential model like this, the only way to get out a negative answer is to have a reflection, which we'll see coming up, but not today. So we're not going to cross the y-axis, the x-axis. We're going to get really, really, really close to it, but we're not actually going to cross it. And I'm also going to graph with my mouse because I tried doing this last time with my fingers and it did not work whatsoever. So I'm going to go ahead and just put my dots. Then I'm going to connect my lines. Those to be a little bit there. And we're going to try and make it go in an upwards fashion. Yeah, I'm going to actually do that with my finger. That was really bad. Again, try and make your pencil line not cross. My arrow keys can cross, but don't let your actual line cross the green dotted line. And then we're going to answer these questions to the right here. So the domain deals with my x values. So take a look. I used both negative and positive and 0 x values. So when I'm looking at an exponential function, I'm really using anything. If I wanted to, I could use fractions, and we know fractions are just decimals. 1/2 is 0.5. It's the same thing. So here we're using what's called all real numbers. And in math, we like to shorthand everything, so we have these symbols. So that symbol there means all real numbers. I'm going to do it again and explain how to do it as I go so that those of you who want to be able to replicate it can do it. So we're going to do a line down. You're going to do a second line, and you're going to create your R starting with the first line and hitting the second. So that's your all real numbers. Well, your range deals with your y values. And think about it. My y's are all positive. We're all going up, but we're bigger than 0. So y is greater than 0. Next, we're going to talk about what happens as we go on and on and on forever without end. We're just looking at this graph in this little tiny window between -2 and 2. So I want to be able to describe it as if it continues like it can. So as x approaches infinity, which is how you read that. So as we keep going and going and going and going and going and going, what's going to happen to my graph? Well, let's see what's happening so far. We see it's going in an upward fashion. So it's getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. So as we continue on in the positive x value, excuse me, my graph will continue in the positive value as well. And we said that it approaches infinity. Because, again, we're going on without end, and so does my graph. However, if I'm looking in the opposite direction, so the negative direction, I'm doing this backwards. No, I did it right. No, I'm still positive. Yep, that way. Wow, this is really hard to do backwards. If I'm trying to look at it in the negative direction, we get really, 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 really close to 0. Now, if you don't believe me, I want you to take the biggest x value you can think of and plug that in your calculator. Take 2 to the negative, blah, 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 and see what you get. You probably got something point blah, 2 point blah to some negative exponent, right? So that negative exponent means that your decimal moves over, which means that we're really close to 0. So as we continue without end in the negative form, we go close to 0. The y-intercept is just where does it hit the y-axis. I can see that on my charts. That is at 0, 1. And then the asymptote, which we said is going to hit the line y is equal to 0. That will constantly be y is equal to 0 until we start moving our graph around, which, again, we won't be doing today, but we will be doing in the future. So we do want to identify that. Number 2. Again, we're going to go ahead and start with our xy table. We're going to pick those handy dandy 5 points again. When I plug in -2, I get 0.11, I get 0.33, I get 1, and I get 3, and I get 9. So I'm going to go ahead and plot those points. Oops, I apologize. Let's do our asymptote line at 0. Now let's go plot our points. So -2 up a little bit, -1 up a little bit more, 0, 1. Oh, that's so little. I don't want my points are barely visible. Let's try that again. Up a little bit more. 1, 3, and 9. Then we're going to go ahead and connect our graph. And again, I'm trying to draw close to 0, but on a computer that's kind of hard to do. So again, my domain is all real numbers. My range, we're getting bigger than 0. If I look at my x's going on and on and on and on and on forever without ending on positive, we go to positive infinity. If I look in the negative fashion, we see we're going towards 0. My intercept is at 0, 1. And again, my asymptote is at y is equal to 0. All right, ladies and gentlemen, what do you think is going to happen with this one? Well, he's a fraction now. So theoretically, according to slide number 1, yeah, it was on the first one, asymptote was the second one. So slide number 1, he's smaller than 1. So he should be decreasing. So instead of going up as we get positive, he should be going down. Ooh, let's make sure that happens. All right, we're going to still use the exact same x values, that -2, -1. Why are you typing z for me? Come on. Now let's go ahead in our calculator. Again, you can do the following. You can do this as a fraction with parentheses around it. Note the parentheses, important key point. Or you can do it as a decimal. And if you notice, it gives you the same value. What? Crazy. So 1/2 to the -2 is 4. Well, we just talked about fractions and exponents. Oh. Think about it, think about it, think about it. I'm going to move, there's everything. Highlight all of you, move you down a moment. Think about what that looks like. Since it's in parentheses, technically everything gets that negative exponent, and we know negatives sink and negatives float. So okay, keeping that all in your mind, what theoretically should this to the negative first be? What's 1/2 to the negative first? Good, it should be 2. We know anything to the 0 is 1. Now, going normally, there we go. Like it was giving me a spinny circle. 1/2 to the first is 1/2, and then 1/2 of 1/2 is 1/4. So asymptote line coming up. Getting a lot of hand here. I have my first dots at -2, 4, -1, 2, 0, 1, 1/2, and again, as long as you get close, guys, I'm not going to count off, but if you're supposed to be like 0.1 and you're really close to 1, be realistic. I'm not going to, oh, it's exactly 0.1, but if it doesn't look remotely close, then you are going to get points off. Let's go ahead and connect our handy dandy little lines. And we're going to answer our questions. So the domain, again, we can plug in everything. We've plugged in positive, we've plugged in negatives, we could plug in fractions. Don't really want to, but we could. My range, my y values are still greater than 0. This is where it's going to flip today. As I'm going in the positive direction, I'm actually approaching 0, and as I'm going in the negative direction, I'm approaching infinity. My intercept is at 0, 1, and the asymptote is y is equal to 0. All right, do another one. Go ahead and determine, pause the video, bloop, and determine those y values for me. We should have the following. So we're going to go ahead and graph my asymptote line and start graphing. Oops, sorry button. Start graphing some points. And we'll go with that one. -2 and 2 1/4. Oh, that's not right. What you? Here. -1, 1 1/2. 1, 6. Again, trying to go as best as you can. Dun, 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 dun. This line. And we should be decreasing. My range is all real numbers again. We're still greater than 0. As we're approaching towards positive infinity, we're hitting 0. And as we go on and on forever without the other direction, we should hit infinity. My intercept is 0, 1, and my asymptote line is y is equal to 0. All right, last one, ladies and gentlemen. I want you to pause the video, and I want you to do it on your own. And then as soon as everyone is done and we're actually doing it and someone's going to go check to make sure someone's doing it, I could call it names, but since it's public on YouTube, I really don't want to. So please make sure that you are getting that done and you're actually trying this. And then I'll show my answer. I'm doing a video. You scared me, by the way. All right, ladies and gentlemen, hopefully your graph looks exactly like mine. We do not have homework today. However, I want you to make sure you fully understand it. And if you didn't understand anything in this video, you can ask me tomorrow when I return. So please, if you have questions, do not hesitate to ask tomorrow. Thank you.